Hey guys, in this video I'm just going to be going over a bunch of different questions that someone sent in, and they all have to do with mainly these two vectors right here. So there's a bunch of parts to this question, and I'm just going to knock out as many as I can. So the first part asks to compute u1 dot u2. So this is just a dot product, so all we do is we multiply the first components of each vector together, so 1 and 2, and then the second components of each vector together, which is 1 and negative 1, and then plus the third components multiplied together, which is negative 1 times 3. So this comes out to be 2 minus 1 minus 3, which is equal to negative 2. Part B asks us to find the cross product of these two vectors, u1 cross u2. So when we take the cross product, we have I, j, k, then we have u1, which is 1, 1, negative 1, and 2, negative 1, 3. So the determinant of this is going to be I times 3 minus 1 minus j times 3 plus 2, and then plus k times negative 1 minus 2. So this simplifies to 2i minus 5j minus 3k, which is the vector 2, negative 5, negative 3. So the cross product of these two vectors is this vector right here. So part C asks us to find the magnitude of both of these vectors, so the magnitude of u1 and the magnitude of u2. So to do this problem, we just use the Pythagorean theorem generalized to multiple dimensions. So for u1, the magnitude of u1 is just going to be the square root of 1 squared plus 1 squared plus negative 1 squared. And this is going to be the square root of 3. So that's the magnitude of u1. And the magnitude of u2 is going to be the square root of 2 squared plus negative 1 squared plus 3 squared. So this is going to equal the square root of 4 plus 1 plus 9, which is equal to the square root of 14. So that's the magnitude of u2. And part D asks us to find the angle between u1 and u2. So recall the formula that u1 dot u2 over the magnitude of u1 times the magnitude of u2 is equal to cosine theta. And this holds for any dimension of vectors. It doesn't matter if the vector is 3-dimensional or 10-dimensional. This equation still holds. So we've already computed u1 dot u2, which is negative 2. And we already know the magnitudes of u1 and u2, which is going to be square root of 3 times 14. And this is going to equal cosine theta. So theta is just going to be the inverse cosine of negative 2 over the square root of 52. So here's our answer. I don't have a calculator on me, so you can type that in yourself. Part E asks us to find the projection of u2 onto u1. So the projection of one vector onto another is defined as u1 dot u2 over the magnitude of the vector that we are projecting on squared, and then times the vector that we are projecting on, negative 2. So we have, this is equal to negative 2 over the magnitude of u1 squared, which is 3, and then times the vector u1, which is 1, 1, negative 1. So this is the projection of u2 onto u1, this vector right here. So that's like saying we have this vector u2, and we are projecting it onto u1, so the projection is actually this vector right here. So this green vector is what we just computed right now. So if we wanted to find this purple arrow, the component of u2 that's orthogonal to u1, then what we would do is we would just take u2 and subtract the projection of u2 onto u1. So if we computed that, that would be this guy right here, this orthogonal vector in purple. In part F, he asks us to find the directional cosines of u1 and u2. And all the direction cosines are the angles between the vector that we're considering and the x, y, and z coordinate axis. So to solve that, we would just use this exact same equation right here. So for F, C part D. And the last part of this assignment that uses these two vectors u1 and u2 asks us to find the area of the parallelogram that is created from u1 and u2. So this parallelogram exists in R3 because these are three-dimensional vectors, but it is a two-dimensional parallelogram because it is only defined by two vectors. So we want to find the area of this parallelogram given that u2 and u1 form the adjacent sides of this parallelogram. So the area of this parallelogram is just going to be the magnitude of u1 cross u2. And we've already determined what u1 cross u2 is, and that's this vector right here. So we'll just take the magnitude of that vector. So the magnitude of 2, -5, -3 is just the square root of 2 squared plus -5 squared plus -3 squared, which comes out to be the square root of 38. So the area of the parallelogram is the square root of 38 units squared. So hopefully this gets you started on your assignment. So good luck, and I will see you guys later.